Hello everyone, this is Ruoyu, and this is assignment 1 for the computer application in power system analysis. Now we'll have several requirements. Firstly, we need to parse the information from the XCIM XML file. Then we need to create an in-memory data structure to store the data. Thirdly, we need to turn the bus breaker model into the bus branch model we need. Finally, we need to calculate the Y-bus matrix of the topology. Now let's start with the parse information part. You see here is the libraries we need to import, and we need to define many classes for the later calculations. Here is the class name and its constructor, and there are many classes in total. Now let's see the parse information part. In order to parse information, we need two functions are used. Firstly, the get function to acquire its RDF ID, and the find.text function to capture the content between the bracket in the CIM XML file. For example, let's see. In order to get this RDF ID, we need to use the get function. But in order to get the value 14 between the bracket of the CIM file, we need to use find.text function. That's how we acquire the information. However, we meet one difficulty during the process. We cannot directly find the base voltage for the synchronous machine, energy consumer load, and the breaker. So we find that there's an equivalent container inside these components. This will guide us to the voltage level below, and from the voltage level we can acquire the base voltage we need. So that's how we get all the information we need, how we parse all the information. Now let's come to the network traversal algorithm.
First, for the network traversal algorithm to find the topology of the system, first is we need to initialize our three equipment in the branch. We have three main equipment. The first one is connectivity node, not a physically existing device, but a logical representation of the common connection point of different devices. The second one is CE, or conducting equipment, can be consist of bus bar, power transformer, and AC line, or etc. And the other one is terminal, which is provide the connection point between the connecting equipment and connectivity node. In our algorithm, first is we need to determine the function to find the next node. In the function to find the next node, if the current node is connected equipment, so the next node will be terminal. And if the current node is connectivity node, the next node will be terminal too. And if the current node is terminal and the previous node is connecting equipment, so the next node will be connectivity node, and vice versa. And to support the algorithm, first we need to find the terminal ID that attached to bus bar, and then we need also to find the connectivity node that attached to the bus bar. In our algorithm, first we need to looping to the connectivity node that attached to the bus bar. So in our algorithm, if the current node is the terminal, we have two possibilities. That is, if the next node is connectivity node, and the next node is connecting equipment. If the next node is connectivity node, we will have two options. The first one, if the CN not attached to the bus bar, then we need to update the current node as the next node, and then for the option 2, if the CN attached to the bus bar, we will need to update the stack and then publish it. And if the next node is connectivity node, is connecting equipment, and we will need to update the next node, and then we need to determine first if the connecting equipment is energy consumer, synchronous machine, linear shunt compensator, and open breaker. And then we update to the next node and we publish to the stack. And if the current node is connectivity node, we will have two options. The first thing is, if there is node untraversed terminal from the list attached to the terminal, and we will update the current node as the next node and find the next node using our function. And then if there is no untraversed terminal remaining, we will publish everything to the stack. And if there is current nodes connected to equipment, and we find again the untraversed terminal, if there is no untraversed terminal remaining, we will publish to the stack. And then we will continue for the Y matrix.
Okay. In order to build the Y matrix, firstly we need to calculate the admittance of all the corresponding elements. From the email, we know that we only need to consider the power transformer and the AC line segments. Here, since it's a double winding transformer, we cannot directly find the information we need in the power transformer list. We need to look for that in the winding list. In the power transformer winding list, we can get the impedance and the susceptance we need here. And according to what we learned in the power system analysis, we can get the per unit value of the admittance of the power transformer. For the AC line segment, we should use the pi equivalent model. From the XML file, we can get the impedance and the susceptance as well. We need to pay attention that we can get the per unit value of the admittance between lines and the two-shunt capacitors. After we calculate the per unit values, we can update the matrix. We can determine the location of the power transformer. We can get which two bus bars the power transformer is between. For example, if the power transformer is connected between bus bar 1 and bus bar 3, then we are updated Y13 and Y31 non-diagonal elements. For the diagonal elements, Y11 and Y33 will also be updated. And things are similar for the AC line segment. If there's an AC line segment connected between bus bar 1 and 4, here, for the diagonal elements, Y14 and Y41 will be updated, and Y11, Y44 will also be updated. Okay, that's how we build the Y-bus matrix.
Now we will continue to database part to MySQL. First is we need to import the MySQL connector that we have done it before, and then we will connect it with the database MySQL in our server. And then we will use MyCursor, our place to execute our SQL query. First is we need to check if there is CM object database exists in our database. It's already exists, we just need to connect it. And if there is no CM object database, and we will need to create first, and then we will connect it. And we will use MyCursor, our place to execute our query. And then first we will make a table for the every CM object. For example, we will create table for base voltage data. First is we need to drop table if it exists, and then we will execute, and then we will create the tables for the base voltage, which consists of ID or RDF ID, and then the value of the base voltage. And we will use RDF ID as our primary key. And then we will insert the base voltage data to the database. And we will use the base voltage data that we already get from our program, and then we will insert it to the database using this SQL query. As you can see in here, there is no CM object database, and we will try to run our program to show it. Okay, this is our simple GUI. As you can see, we have three options here. First, import EQ file and import SSH file, and then we run it. First, we will import EQ file, and then we will import SSH file, and then we will run it. Okay, and we will show you. As you can see, that same object database shown in our MySQL database, and it's already contain the data that we extract from the XML. So this is why bus matrix that after we run our program.
Now I'll show you the flexibility of our program. If we edit one value in the XML file, are we going to see the change in the result? Let's see. In the SS file, let's suppose that we let one breaker open. You see here we turn the value from false to true. And save it. Then we run the program again. Select the EQ file and SSH file and run it. As you see, the value y11 and y15 become 0, which is different from the original one. It means that our program is very flexible.
I will show you if our program tries to run with the XML with the bigger topology. Let's try run our program again, and then we will import the configuration with the bigger topology. This file, and then we run it. As you can see that the bus matrix show that the XML file has 9 bus bar, and it's more complex than before, and it can works as well. And in the database also, it has more data content than before. If we refresh it, okay, as you can see that we have more data in here, more data comparing to the simple one. Okay, I think it is our presentation about our assignment 1 for computer application for power system analysis, and I hope you enjoy it. Have a nice day, and thank you for watching. Thank you very much.